Hey, welcome to my channel. My name is Swapna. In DSP, the today's topic is elementary signals. The different elementary discrete time signals which we are going to discuss today are unit step signal, ramp signal, impulse signal, parabolic signal, exponential signal, and sinusoidal signal. The signal can be replaced by the name sequence. As the signal is discrete, we can call it sequences. Now, one by one, we'll see. First is the unit step signal. According to the definition of unit step signal, it is denoted by u of n and it is equal to 1 for n greater than equal to 0 and equal to 0 for n less than 0. As shown in figure, the amplitude of each sample is 1 for n greater than 0 and 0 for n less than 0. This type of signal we call it as a unit step sequence. Then unit ramp sequence, which is denoted by R of n, which is equal to n for n greater than equal to 0 and 0 for n less than 0. It is gradually increasing. Here the slope is considered 1. That's why the name given unit ramp. Coming to the next signal, we call it as the impulse signal or sample signal. It is denoted by delta of n and defined by delta of n equal to 1 for n equal to 0 and 0 otherwise. So at n equal to 0, the sample value is 1. We call it as a unit impulse sequence. Then in unit parabolic sequence, the equation is given by n square by 2 for n greater than equal to 0 and 0 otherwise. And the graph for n greater than 0 for n square by 2 is as shown in the figure. So it obeys the parabolic path, hence we call it as a parabolic sequence. Then exponential sequence. This is a general equation of exponential sequence for a discrete signal. It is denoted by a alpha to the power n. A can be the initial amplitude. Alpha is some constant where n is a variable. Depending on alpha, we can have the exponential decrease or exponential increase. If the value of alpha is between 0 to 1, we will get the signal which is exponential decreasing discrete signal. Whereas if alpha greater than 1, we'll get all the samples, the amplitude gradually increasing. If the alpha value is between 0 to minus 1, again it is exponential decrease but one sample up and one sample down. Similarly, if alpha is less than minus 1, this is the exponential increasing signal with one sample up and one sample down. Hence, depending on the values of alpha, we have the exponential signal which can be exponential decaying or exponential increasing. This is an exponential signal. Coming to the sinusoidal sequence, the general equation of sinusoidal sequence is given by x of n equal to a sine omega n plus phi. A is amplitude, omega is the angular frequency, n is here the x-axis and phi is the initial phase. So the discrete sinusoidal signal can be shown in the figure. Now we'll go for the classification of discrete time signals. The discrete time signals are generally classified as energy signals or power signals, periodic non-periodic signals, even and odd signals, causal and non-causal signals. So energy signal. A signal is said to be energy signal if its energy defined by Ex is finite and the energy of a discrete signal is given by summation n equal to minus infinity to infinity mod of x of n square. If this energy Ex, if it is less than infinity, the signal is said to be energy signal. Similarly, a discrete signal x of n is said to be power signal if the power content is finite and the power is calculated using the formula limit n tends to infinity 1 divided by 2n plus 1 summation n equal to minus n to plus n mod of x of n square. Now here 2n plus 1, it denotes minus n samples on left side plus n samples on right side and the 0th sample. Hence the total number of samples are 2n plus 1. That's why it is there in this formula. Now, as we know, there is one relation between energy signal and power signal. The power signal, the average power of a periodic signal can also be given as 1 by n summation n equal to 0 to n minus 1 mod of x of n square. If the signal is energy signal, its power is 0. That is, if E is finite between 0 to infinity, the power P equal to 0. And the signal is an energy signal. If the signal is a power signal, its energy is infinite if the finite power is finite and non-zero. Coming to periodic and non-periodic signals. The signals are said to be periodic if they repeat at equal interval of time. Here time means number of samples. Thus a discrete time signal is said to be periodic with a period capital N if and only if x of n plus capital N is equal to x of n, and the smallest value of capital N which satisfies this above equation we call it as a fundamental period, and this fundamental period can be given as 2 pi by omega. If it's not satisfied, we call it as a periodic signal. Even signal and odd signal. A discrete time signal is said to be even signal if x of n equal to x of minus n for all values of n, while a signal is said to be odd signal if x of n equal to minus x of minus n for all values of n. So the even signals are symmetric signals, while odd signals are antisymmetric signals about the vertical axis. Coming to causal and non-causal signals. The discrete time signal is said to be causal if x of n equal to 0 for n less than 0. Otherwise, the signal is non-causal. This is a simple definition. And if the signal exists for n